Okay na. Okay. This is our block diagram that compromises our hardware connections and our software capabilities to successfully finish our project. Um, First of all, meron tayong analog interface. So, discuss muna sa inyo pero hindi ganito sa discussion ko. Sa in actual. So, we have the analog interface. Ito yung interface natin for us to get analog data. This compromises of two integrated circuits known as the digital to analog converter and analog to digital converter. So, in our analog side, no, so we are using this product, we are using this technology. So one might ask na this analog ito bang analog interface na to ay pwedeng gamitin as your digital interface? Now, the short answer is actually yes, but it is impractical. What do I mean with impractical? Di ba? We are using ADC for us to have a better resolution. So, kapag gagamitin natin siya as digital device or digital na 0 and 5 volts, so na-disregard natin yung resolution, yung mismong concept ng paggamit ng ADC and DAC. So, for our analog interface, these combinations of ADC and DAC technology yung gagamitin natin. So, ito yung sa analog side, di ba? And ganyan sabi ko kanina, for our analog interface, we have 4 channels. So, when I say channels, ito yung available ports na pwede natin gamitin. Next, we have the digital interface. Kuha ko ng laser. So, we have digital, wait lang. Digital laser pointer, okay. We have digital interface. Ngayon, nung unang-unang meeting talaga natin, talaga nag-focus lang tayo on DAC and ADC. Tapos later on, as we progress, no, as we learn about this project, lalo siya nagiging mahirap actually. Lalo siya mas nagiging complex at lumalabas, lumilitaw yung mga flaws. Which those flaws, ano ba yan, maaaring doon tayo mag-fail. So, furthermore, to add flexibility to our device, nag-include ako ng isang digital interface. Digital interface is simply if you want to transfer data ng 0 volts and 5 volts. So, you are not concerned about the resolution of that voltage. Hindi mo concerned kung 5.106669 volts yan. You're just concerned kung merong voltage or wala. Okay? On or off, 0 or 1. So just concerned with that. Pero as you can see, no, we have digital input directly connected to our microcontroller. For this reason, 5 volts lang kasi siya. So our devices is 5 volt tolerant. So when someone asks you na gumagana ba yan in 12 volts, no, it's not. Everything in our devices are operating under 5 volts tolerant. Now, as you can see, no, we have digital input. So, if you see a arrow pointing to where it is, ibig sabihin yung data papunta doon. Kapag yung arrow naman, away, yung data palabas. So, in this case, ito nga yung arrow papunta dito sa microcontroller, ibig sabihin, those are inputs. Diba? Yun yung mga binabasa ng microcontroller natin. Now, we have digital output, but this digital output is not connected directly to your device. So, ibig sabihin, etong input yan eh. Bakit yung output, naglagay pa ako ng power transistor. So, what power transistor is? Ganito kasi yan. Yung mga microcontroller, each pin, lahat ng pin na, yung sa familiar kayo, di ba, sa Arduino Nano and Arduino Uno, yung output ng mga pins na yon, lahat yon may limit na sinking current. So when we say sinking current, ito yung maximum current na kaya nang ilabas. Okay? And the maximum current the microcontroller can offer would range around 20 milliamperes to maximum of 50 milliamperes. Now, that 50 milliamperes is just enough to simply light an LED. Kaya makita niyo yung mga project niya, 7 segment directly connected yung output pin ng microcontroller kasi it can drive the LED itself. Pero for high current application, such as motor, bulbs, so on and so forth, the digital output pin of a microcontroller is not enough. So for this reason, nagdagdag tayo ng power transistor. Nang sa gayon, kaya niya mag-deliver ng current up the maximum of 2 amperes. So 2 amperes is enough. It can drive a motor. So the question is, it can drive an LED? Yes. Pero overkill. When I say overkill, parang ito naman yung kinukuha ng LED is roughly around 20 milliamperes, pero yung transistor kaya niyang deliver ng 2 amperes. So, for this reason, pwede nang magamit yung device natin for a wide variety of application at the same time, mas safe yung device natin. What I mean is, regardless of anumang current no, na madraw niya, ang unang-unang masisira sa atin is yung power transistor. Hindi masisira yung output pin ng microcontroller, which is, kapag nasira yon, it might affect the whole microcontroller itself. Kapag nangyari yon, maaaring yung buong system na rin. So aside from that, we also have our internal access register. Kaya sasabi ko parati, no? This IAR holds the data in strings, no? So ito yung i-store ng data, whatever the string is. So when we say a string, it is a collection of characters. In layman's term, word siya, no? So let's say sa bank A or sa folder number 1, ang laman niya is microcontroller. Sa folder number 2, ang laman ng word name is base. Sa folder number 3 is IoT. So, for the particular reason, pwede mong kuhain yung data na yon anytime, anywhere, since connected tayo sa cloud. Pero as you can see, hindi ko dinarekta yung UART natin so kung saan ka man magsasend ng data. What I mean is, hindi ko dinarekta na yung lahat ng data papasok mo is directly to the UART of this microcontroller. Isa naman yung reason ko dyan. Bakit nilagay ko ng RS-232? RS-232 kasi is an industrial, layman's term industrial-based na UART. Kasi UART is not that, protected from electrical noises. So, let's say for example, no, yung IoT natin at yung computer natin, ino-operate mo siya, let's say, from your computer, your IoT device is connected for 5 meters. Or let's say 2 meters. UART lang, mag-work yun, gagana yun. Pero kapag yun ay lumagpas ka ng 10 meters, hindi, yung signals mo magde-deteriorate rate kasi humahaba yung wire mo, since may resistance yun, maaaring hindi mabasa ng microcontroller yung data mo ng maayos. So for this reason, ang ginagawa ni RS-232, yung 5 volts tolerant nung signals natin from UART, tinataas niya into 12 volts. So ibig sabihin, kahit mahaba yung wire na yan, pwede tayo magpasok at mag-send ng data. And okay yung ganyang setup dahil hindi naman lahat, alam mo yun, if this IoT device is connected to a machine, hindi naman to may yung laptop mo, hindi ka naman nakadikit dun sa machine, di ba? So, maaaring risk yun or hazard yun kapag malapit ka sa machine. So, long wires connected to RS-232, then UART. Next, we have the Internet of Things, yun nga, na again, connected to a UART. So kasi 'di ba, we have two microcontrollers. We have the AVR and we have the expressive microcontroller. Ang isang reason nun, isang question doon is, paano ko magta-transfer ng information from my AVR to my expressive? No, the technology or serial communication protocol we are going to use is again the UART. So puro tayo UART dito. Kasi ito yung simplest and most efficient. So we have the UART na connected to the ESP32WROM32. And for our programming and debugging, so syempre, paano natin ipoprogram si microcontroller itself? Dalawa, no? We have two options. Number one is to use the Atmel eyes. Atmel Eyes, i-search nyo to, syempre. Dapat pa rin na alam nyo to. Si Atmel Eyes, this is a programmer intended for a VR microcontroller. Actually, nakabili na ako ng Atmel Eyes, so medyo costly siya. 7K siya. Pero hindi ko na, I mean, hindi na tayo bibili. So, since I have this equipment na naman. So, yung Atmel Eyes, for it to program your microcontroller, ang communication protocol nun is SPI, okay? In any case na hindi tayo gumamit ng Atmel Eyes, we're going to use the UART or the bootloader. Kasi ito yung, so search nyo yun ha, what is communication protocol, what is bootloader. Now UART, if we use UART, we're going to use the USB to serial TTL. In any case na mag-use SPI tayo, Atmel Eyes. So the question remains, what is the best? Depende pa rin. If we're concerned with flexibility, we go with the UART and USB to serial TTL. And if we are concerned with the reliability and further features, ibig sabihin may iba pa siyang kakayahan kaya sa aside from programming, we'll go with the Atmel Eyes. Pero for our device, mag-Atmel Eyes tayo. Pero during our turnover ng device kila Sir Mamarado, we are going to convert to the UART kasi UART para mas madali nila ma-program yung device for their future use kung ano mang kailangan lang gamitin doon. Bakit Atmel Eyes? For one reason, the Atmel Eyes supports debugging. So when we say debugging, ito yung kakayahan ng EVR natin na i-run yung code line by line. So kung merong mali doon sa device natin, we can figure out saan specific line tayo magkakamali. Next, we have online controls. Okay. Medyo dumadami, no? Di actually dumadami, mas nagiging malinaw na. So, napansin nyo, no, na ang unang device natin or unang ginawa natin is meron tayong analog interface. Meron tayong digital to analog converter and analog to digital converter. So, meron tayong ADC and DAC. Pero ito tanong, after noon, ano na? Di ba? Like, okay, di ba? Pinapakita mo yung voltage doon, and at the other side, nilalabas niya yung exact voltage na nakukuha mo. Ano ngayon? So ano yung application nun? Hanggang doon na lang, no? Parang napaka-limited. So kaya naglagay ko ng online controls. Online controls extends our flexibility of the device. So meron tayong relay na yung relay na yan, so when we say online, ibig sabihin, from the other side, no, from your station A, you can control the relay and the MOSFET on your station B. Okay? Again, online controls, ibig sabihin, from your station A, you can control the relay and MOSFET to your station B. So in reverse, we can control the relay and MOSFET on station B via station A. So parang vice versa siya. So relay, ibig sabihin, we can control high voltage devices such as AC, no? It can works on DC as well, pero for this specific application, parang mas reliable siya for AC connections. And we have MOSFET nga for relay. We have MOSFET pala for DC voltages. Now, dito mo ipapasok si ating human-machine interface or HMI. Mali yung nasasabi kong word. This is not GUI since wala tayong software application. Meron tayong HMI. Hindi po GUI, HMI. Whereas that HMI serves as two purpose. Okay? Number 1, for monitoring. Number 2, for controls. Ano ibig ko sabihin dito? If you are going to take a look to our proposed, no, na gagamiting display, meron dong characteristic kasi ang gagamitin natin is Nexon Intelligent Display, no. It has 4 Actually, 8 pala, so sorry. It has 8 extra GPIO pin. Okay? So aside from the microcontroller, yung HMI mismo, meron siyang extra 8 na GPIO. Na kaya niya ring mag-act as a microcontroller. Okay? So ginawa ko ganito. Remember, we have online controls. Okay? So ibig sabihin, from station A, I can control the relay and MOSFET on station B. But what if gusto kong kontrolin yung relay and MOSFET ko sa station A? Nag-gets niyo ako? So ibig sabihin, etong device natin, kahit wala yung station B, kasi for example siguro, no, namatay siguro yung wifi ng station B, mayroong part pa rin sa ating station A na pwede mong kontrolin through the HMI. So, tinawag ko siyang offline controls kasi extra peripherals to. Yung relay dito at yung relay dito, hindi yan magkapareho. Okay? Yung relay and MOSFET na to are reliant to our HMI. So ngayon, alam mo yun, ma-extend yung capabilities natin. Let's say for example, gusto ko mag-control mismo dito sa akin kasi ang ang finokus natin ano eh, di ba? Controlling of the other side. Yun yung finokus natin nung una. Controlling yung sa kabila, sa kabilang station. Pero paano naman yung station natin? Di ba? Yung ditong station, paano naman yun? So wala na. Wala na tayong capabilities. So next capabilities natin by utilizing the extra GPIO pins of our display. So, naglagay ako ngayon ng relay and MOSFET. And digital input monitor, digital output control. So, ito lang yon. And last but not the least, ito yung, which I think optional, pero ito natin kay sir. Pero as of today, gusto ko itong ilagay, pero we're waiting for the approval kung talagang mas gusto nila na external host MCU. Bakit na external host MCU? Banda natin yung microcontroller, tatlo na. So we have the AVR, we have the expressive. Ngayon, we are limited to the functionalities of our device depende sa mga nilagay natin, no? We have the online controls, digital interface, analog, IAR, offline controls. So the question remains the same, no? Like the question is, what if I want to do more? Okay? Doon na tayo papasok eh. Ito na yung pinakamalak. Kasi sa lahat ng maaaring magbutas ng thesis natin, no? What if I want to do more than what you offer to us? Di ba? The answer is external host MCU. What do I mean with this? Yung external host MCU, it has the capability of extracting all the data of a station A and a station B. Lahat ng data. And it's up to you kung paano mo gagamitin yung data na yon. And when I say it's up to you, eto na ngayon, dito na ngayon papasok yung flexibility ng device natin. It's up to me, no? For what specific application ko gagamitin siya, since meron no external host MCU, I can program this host MCU and therefore, mas magiging flexible yung device natin. So, eto yung ating block diagram. Ngayon, yung ating microcontroller, ang gagamitin natin is AVR at Mega 2560. So, nung una, this is at Mega 328p. Okay? Pero hindi ko sasabihin yung reason. And I want you to have your own research and matatanong ako bukas, please, sa may alam, huwag yun na sabihin sa iba. Alam ko merong may alam dito eh, kung bakit at Mega 2560 yung ginamit ko. Please, huwag mo na sabihin sa iba kung bakit ayun yung ginamit. Let them have their own research. So, I want tomorrow, so bukas malaman kung bakit either 80 mega 2560 yung ginamit instead of 80 mega 328 nung una nating pinopose. Next, for our analog interface, we have the AD5667 and ADX115. Both of them have the capabilities of extracting data up to 4 channel Actually, si ADS 5667, 2 channel lang siya. Sa ADS 115, 4 channel siya. So, Vince, gagamitin natin. Simple, yes, it is. Dalawa. Kasi, pala ko talaga isa lang. Pero kasi, alam mo yun, hindi nag-eksakto. Sa ADS 115, 4 channel. ADS 5667, 2 channel. So, sayang naman yung extra 2 channels ng ADS 115. Eh, yung ADS 5667 naman around 200 lang at or 300 pesos. So, 2 AD 567 na gagamitin natin. So, for our digital interface, we're going to use an N-channel MOSFET, our IRF-Z44N. And for our Nexon, for our display, ang gagamitin natin is Nexon Intelligent 7-inch capacitive touchscreen display. So, may sinend ako na link doon kanina pa doon sa ating GC. So, hanapin na lang doon. Andiyan naman yung details na yun. 7 inches, no? Capacitive siya, hindi siya resistive, touchscreen siya, and display siya. Okay? So, for our relay, kasi the capability of holding up to maximum of 220 volts AC, maximum of 10 amperes. Nice. For our MOSFET, same, N-channel MOSFET Z44. And actually, may reason kung bakit N-channel MOSFET yung ginamit ko. Kasi, we are going to utilize the pulse width modulation of our microcontroller. So, may sense kung bakit N-channel MOSFET siya. Kasi, utilize natin yung PWM. Kung ano yun, huwag mo na ngayon, siguro, future discussion na lang. So, for our online controls, merong N-channel MOSFET. Next. So to our Internet of Things, ito rin na iba. Di ba remember yung sa discussion ni Kevin, ang microcontroller is Tensilica LX7. So, we're not using the IC itself. So, baka magkaroon ng misconception. Kasi ito yan eh. Si AVR80 Mega 2560, yung IC mismo talaga. As in literal na IC mismo. Now, si ESP32, etong sa ating IoT, yung LX7, hindi ko siya hirap siya, is way too complex for us, and para sa akin na rin, i-program siya. So, we are using the ESP32. Pero hindi ESP32 module, ha? Hindi yung module, yung ESP32 lang. Kasi ano to eh, parang module, yung extensively na yon, IC yon. Now, yung ESP32, ayun yung LX7, ayun yung Tensilica LX7 na naka-module. Ang tawag doon, ESP32. Now, yung ESP32 module, na nilagay pa sa module, ang tawag naman doon is ESP32 module. So, confusing to ha. Pero we are using the ESP32 lang. Hindi yung mismong module lang. Hindi yung mismong module. Next, for our external host MCU, Arduino Nano. Okay? So nakita mo, sa lahat-lahat to, lahat-lahat, ito lang, yung talaga merong specific. I mean, not specific. Ito lang yung device na talagang ginawa. Na talagang nilagay ko yung term, Arduino Nano. Yes, it is. Kasi maraming developer ang gumagamit ito. Mas sikat to, mas madali. So, kaya nilagay ko talagang pinpoint ko na, oy, ang external host MCU natin is Arduino Nano. And for our AIR, Max 232. Okay? So, I want everyone again to have their own research regarding AD5667, ADS1115, AVR80 Mega 2560, IRZ44, and Max 232. Kasi, kailangan natin mag-focus sa mga yan. Kasi, yung magiging backbone natin. Magiging backbone ng device natin. So, totoo lang ha, in comparison to other group, mas swerte tayo pa rin na ito yung napili nating title. Kasi, lahat to, pure electronics, and ito naman talaga yung field natin, di ba? After all, ito talaga yung field natin. So, wala tayong mga metalworks, wala tayong mga, ano yun, paggawa-gawang bakal kung ano-ano. So, alam mo yun, just going to sit, no, to understand each and every one of this. So, to take a final look, ito yung ating block diagram. So, I've created a block diagram using Microsoft Visio. Pero, ibibigay ko sa inyo yung PDF format para mas maaral nyo, as well as this presentation. So, that's the end of my discussion. So, dapat talaga meron pa to. Pero sobrang kinapos na ako ng oras dahil pinerfect ko masyado tong ano natin. So,